make a triangle that says this. And I'll call that W maybe. Okay? It can be any letter you want, doesn't really matter. Okay. Can somebody please tell me how to find W? Yeah, no, go. Okay, so W squared equals 10 squared plus 11 squared. That's W squared equals 100 plus 121. W squared equals 221. W equals, you can answer that? No, if you can answer that? You don't get it? 14.87? Okay. Now, I feel good about that answer because that's the biggest side. Okay, so definitely when you do this, 10 and 11 are going to be shorter, and 14.87 will be, in fact, the biggest. Okay? All right, Jenna, I'm going to redraw the second triangle. It looks something like this. Okay, so there's going to be an 8. What other sides can I put on there?
14.87.
Yeah, it's going to be on here, I think. And I'll call it J since your name is Jenna. Okay, Jenna, how do you solve for J, please?
14.8 squared plus 8 squared.
Yes, so J squared equals 14.87 squared plus 8 squared. Now, this is the magic of trig, at least I think it's magical. Can somebody tell me without using a calculator and justify what's 14.87 squared going to be, Calvin? How'd you get that? You have a magic, you do that in your brain. How'd you get that? Right on. We took the square root of 221 to get this number, so when you square it, you should go back to that number, right? Okay, so I'm going to call that 221, and I'm going to call that 64. So I'm going to say J squared equals, what is that, 285? Megan, take a square root of 285 for me, please. And just to embarrass Megan and everyone else here, please make sure you have your calculators ready to go for this unit. Trig is sort of calculator heavy. Okay, so if you've been someone that's been forgetting the calculator, which nobody, you guys are all awesome. Have I told you guys you're my best class for everything? Okay, let me tell you again, you guys are my best class for everything, okay? So make sure your calculator's all handy. Okay, Megan, square root of 285 is what? 16.88. Now, once again, why is 16.88 reasonable for that? The biggest side, right? It's got to be. All right. Okay, so Karina, now I'm going to draw the third triangle in red. I'm going to have a 9 on the top, and that's supposed to be a right angle. It doesn't really look like it. I'm going to have an X. What goes on the left-hand side? 16.88. Okay, good. So how do I solve for X, please, Karina?
X equals 16.8 squared plus 9.
Close, but no, I apologize, okay? Now, the reason is, can somebody justify why I'm sorry to say that? Yeah, why is that not quite going to be true? Yes, okay, yes, and that would be it. But I want something simpler than that. That's true, okay? Let's just slow it down a little bit.
You're not solving for C squared?
Yeah, if you, basically your hypotenuse here, you're right what you said, but I'm just going to say this. Your hypotenuse here is along the side, okay? So I'm going to call this as the biggest side, which is this. And again, Liam had a way he learned it that Noah had a way he learned it that he'd be subtracting and all this sort of stuff. Let's just start with this right now. Can anyone in their head tell me what 16.88 squared is? What 16.88 squared is going to be? Bailey, go ahead. 285. That's amazing that you do that in your head. Again, if you don't know where she's getting that from, it's coming from right there, okay? And 9 squared should be 81. Yeah, you can, right on. Okay, so Des, right. If I want to solve for X, what's the next step here, please? Right on, okay? So 285, and again, you'll get the same answer as this here. So 285 minus 81 is X squared. That happens to be 204, I think. Is that right? Yeah. Okay. Natalie, can you take the square root of 204 from me, please? It better not be the same answer you got, or else I'll be very upset. 14.3. No,
I mean 14.28.
Okay, so Caleb was a little bit off, okay? I would strongly recommend on this question, it doesn't take that long to draw out 3 triangles. It makes the question a lot simpler, okay? Whenever you see things that are like multi, and in this unit I want to try and be mean, there will be lots of multi-triangle questions, okay, as we keep going with the word problems. So just to draw them out makes the question a lot easier, okay? Any question about this? Okay, Let's get going with today's lesson. I can pause it here while I find my lesson. Sorry about that. It's in my computer. I know exactly where it is. It's just not out. Starting a new unit today on triangles, trigonometry, which is nice. Quadratics is done. Factoring, completing the square, quad formula, all that stuff is done until the final exam, but we'll talk about that in June. Today our title is going to be Congruent and Similar Triangles. Okay, we're going to say two triangles may be congruent, similar, or neither. Okay, congruent is a word that you'll probably never hear outside of math class. I've never heard that word before. Yes? Do you know what it means? The same, okay? It means that these two things are going to be the same. So, we're going to say two triangles are congruent. If they have exactly the same shape and size. And we're talking mathematically how to prove this today. Because unlike in elementary school, if you did this sort of stuff where you could just put things on top of each other and spin them and all that. Remember, I am an awful triangle drawer. We've said this. Okay, so you have to use the numbers and all that instead of using the actual pictures. Two triangles are similar. I'm going to try to work this together in over here. If they have the same shape and a different size.
Yeah.
I'm going to put in bracket models. Now, I'm not talking about people that walk down the front line. What I'm talking about is, I used to, when I was a kid, for probably about my 9th or my 10th birthday, my father got me one of those miniature cars. So, like, where there'd be like 1,000 pieces, you could glue them all together. I had like some sort of Lamborghini that I got. And it said on the side of it, stay with me here, please. It said on the side of it, scale 1 to 100. What that means, it looks exactly proportioned, exactly the same as the real deal, but it's just a lot smaller than it, okay? So that's the same thing with similar triangles. It's going to be the same shape, exactly the same, except for it's bigger or smaller than the original, right? And these two fundamental things are sort of the foundation of higher math here. I'm going to pause the video, then I need to yell at Caleb for a sec. Caleb? It's like I didn't even lose my mind there. Okay, here we go. So minimum conditions for congruence. Okay, we're going to say. In Condi plus ions, it's not Condi plus ions. Congruence.
That's not what it says.
All right. Goodness gracious. Okay, I'm going to pause the video and start to yell again. All right. When I first was a baby teacher, okay, I'm going to stop this video. I'm going to stop this because we need a break here. For barf.